Hey there, coders. Welcome back to another exciting episode in our Rust programming series. Today, we are diving into one of the most unique and powerful feature of Rust, that is ownership. Rust's ownership model is what makes it so memory safe or efficient. But if you are new to it, it might seem a little doubting. Don't worry, by the end of this video, you will not only understand ownership but also be able to explain it to others. First, what is ownership? Ownership in a Rust is a set of rules that govern how memory is managed in a Rust program. Unlike languages with garbage collection like Python or Java, or manual memory management like C or C++, Rust's ownership system ensures memory safety without a garbage collector. Here are rules of ownership. Each value in Rust has an owner. There can only there can only be one owner at a time. When the owner goes out of scope, the value is dropped. The compiler enforces these rules, ensuring your program is safe and free of common bugs. Uh, Next, understand difference between stack and the heap. Before we jump into code, let's understand two main memory storage area, the stack and the heap. Stack. Stack data st- stack stores data in last in first out manner. It is fast but require fixed size data. Now heap. Heap store data with dynamic sizes. It is slower because it requires memory allocation and deallocation. Again, I am repeating stack stores fixed size data known at compile time values, organized as last in first out, fast and efficient access. Heap stores dynamically sized data, memory is allocated and deallocated at runtime. Accessing data is slower due to pointer indirection. Now open up your code editor and start editing. Start coding. First, scope and ownership. First, make a block. Sorry. First, make a block. And we create a string using string from. This allocates memory on the heap and s become the owner of this memory. Let's create and print it here. Here, here the main part comes in. S is not valid here. S is not valid here. S come S comes into scope here. S S can be S can be used within this scope. Now, here S goes out of the scope and not valid here. Now, I'm explaining the code line by line. Here, a block is created. Now, the variable S is not valid here. We create a string using a string from. This allocates memory on the heap and S becomes the owner of this memory. We print the we print the string which works because S is in the scope here. Here the block ends, S goes out of scope and the memory is automatically deallocated. So if you run the program, sorry, cargo run, it will print hello. But if you try to access that out of scope, it will throw error. Error is not found in this scope because S is not in this scope. S is not valid here. Now, in the next part, string literal and string type. String literal are stored on stack, are immutable and known at compile time. After that, the string type is stored on the heap, is mutable, and its size is determined at runtime. Let's see in the code. Removing this code, let x equals 5, let y equals x. Here, x is copied because integer implement the copy trait. In the next line, we can access both x and y. If we run the program, both x and y is accessed. But in the string case, there is something different. S1 and S2 equals S1. Here, ownership is moved to S2, and now S1 is not valid, means S1 is now invalid. If you want to print S1, it will throw error. First I am printing S1, and error shows that it is not valid. Value borrowed here after move. So it is not valid here. S2 is valid. If you run the program, S2 is hello. But if you use dot clone method, using dot clone method, we create a deep copy of the string. I'm showing how it done. S3 equals S2 dot clone. Println S2 S3. Using dot clone, we create a deep copy of string in S3. So both S2 and S3 are valid. Here both S2 and S3 are valid. Now we move to function and ownership. Let's remove this. Let us remove this. First create a function named takes ownership. Takes ownership. Then create a function that makes copy. The takes ownership function takes ownership of the string passed to it. Once the function ends, the memory is deallocated. But in the makes copy function, the makes copy function copies the i32 file, means the integer type. The original value remains valid. Let's see in the main function. Let s equals string underscore underscore from hello, and I will call takes ownership here. Let's run the program. Here s is ownership of s moves to take ownership function, means s is not valid from here. If I want to print s, error comes here. Error is value borrowed here after move, means s the ownership of s is moved to this function. Now s is not valid here, so comment out here and make a integer type and call makes copy function. From here x is valid. I'm calling x, printing x. Here x is valid. Why it is? X is copied into make makes copy function, so it remain valid in the main function. X is copied in this function, not moved. X is copied, whereas S is moved. S ownership is moved to takes ownership function, and X value is copied to this function, makes copy function. Understand? So X, we can use X in main function. So so we cannot use S in main function. That's all. After that, returning ownership. Let's remove this code, also remove this, and write a code. Fn return ownership, return ownership, ownership, and take string. Here, returns ownership takes ownership of S and return it. See in the main function. Let S1 equals string from hello. Let S2 equals return ownership S1. Ownership of S1 moves to return ownership function. Here, ownership of S1 is moved to return ownership function, and after that is returned to variable S2. So we can use S2 here. Hello. So in the summary, that's it on Rust ownership. Today we covered its rule, how it manages memory, and how variable interact with ownership. By mastering ownership, you will write safer and more efficient Rust program. And that's it for this video. I will see you in next one. Let's keep watching and building with Rust. Thank you.